So today I'm going to tell a tale of admin credentials and the people that would love to use them. So in a slide that will probably surprise very few people in this audience, system administrators have access to many things, right? So you have your network switching and routing equipment, you have the IPMI interfaces for the hardware that actually runs in your cloud, you have the operating systems that run on top of that. You have some cloud platforms. You may be running OpenStack or Mesos or Grid Engine. And as administrators get more and more access into the source code of our business applications, but not only that and also the infrastructure as a code bits, it's easy to see that system admins have unrestricted access to lots of security sensitive bits and pieces, right? And that makes you a lovely problem in the sense that people would probably like to compromise your credentials, right? So I get the impression that tomorrow's keynote speaker is probably going to speak a little bit more about this. But a common way for admins to have their credentials taken away from them are phishing attacks, right? So we think of phishing as a fairly unsophisticated attack, but if you're actually targeted by somebody who really wants these ones, maybe they'll make it look a lot better. And so you get your email on your admin laptop, and then you connect directly to your cloud controller network or sensitive network, and that makes it unhappy, right? Alternatively, your organization may worry that the admins they hire are not necessarily the most trustworthy, and just by virtue of having that person, they have also contaminated that separated network. And these are problems for organizations large and small, right? So if we think of what happened during the Sony attack, certainly they did not get owned by credential theft, but once they did have the credentials, they had free reign on that network, right? Similarly, this has happened within the government. Similarly, this has happened in smaller organizations and startups, right? So if we think about what happened to Codespaces, a Subversion hosting service, they had their Amazon root credentials taken. Somebody tried to hold their data hostage. They did not have the money to pay, and they went out of business, right? So all bad things that happen because of credential theft. And so if we look at how we protect a network today, there are three main ways that we try to protect these sensitive networks, right? So we have firewalls. I'm sure everyone here is familiar with what firewalls are. They don't really give us a great idea of who is using that laptop on the other end, but we've at least said that, hosts from this particular IP address or maybe this subnet, they can access this network, right? Similarly, with a VPN, I imagine nobody here is a stranger to what a VPN is. You connect to a concentrator, and your laptop is then on that sensitive network again. And in both of these cases, we really have to focus on the security of the endpoint itself, right? So we have to make sure that that endpoint is well maintained, has the appropriate patching and whatnot. And we also have to trust our administrators on that. And it makes it also really hard for us, even if we are fully patched and whatnot, to correlate what happens between what the admin does and what is actually happening on this sensitive network. The third way is a bastion host. We can put a host in between both networks. You connect to that bastion host, and then you use SSH or other administration tools to connect to the other network. And we believe that this is where we can really we can really get some ability to impact these malicious clients and these laptops that may not have great endpoint manageability through this secure auditable bastion host. Bastion hosts are great, but it's easy for another person in the organization to maybe implement them insecurely. So it's possible that somebody just takes a machine, puts it on both networks, calls it a day. Hey, we've made a bastion host, right? So the problems with this are, of course, that the auditing story may not be as great there, so they might not have set up any log forwarding, not a good thing. They might not have set up any system resource collection or data collection or appropriate firewalling. In turn, they are kind of a massive single point of failure, right? So this is not a good thing. If you own this bastion host, you have then you have the ability to really go in to see what your admins are doing day to day. You can find out what commands they run. You can try to bug those commands. It'll be fun. So we wanted to make something that would be like the bank vault door and the camera watching the bank vault door. to be able to see what happens and be extremely hard to disable this vault. So even if they do get in, we have a good idea of what they did to get in, and we can go from there and actually figure out what happened. Now, in the process of building a security system, it is important to think about a threat model. And a threat model is kind of a statement of assumptions that you decided that you were going to take into account when you built a system, right? And if you build a security solution and you don't take into account who your adversary is or what they might look like, then you're just kind of doing security for security's sake, and that's no good either. So when building our system and sitting down and thinking about how we could really improve the state of connecting to these sensitive networks, we thought about a remote attacker that was trying to persistently access this juicy network. They might have compromised a valid admin's source system or credentials. We believe that this attacker or adversary can compromise the applications inside of the container, and this will make a little bit more sense in the next slides, that face the remote network, and they can't break the container isolation, which we'll also talk about. We believe that the attacker can't compromise the control process that is used to actually take input from our web application and deploy the containers. And we also have to take into account the proper configuration of SSH and use of multi-factor. So given all of these inputs to our system, we created something that we call Spyglass. And Spyglass has 4 main components to try to address some of these bits in our threat model. So we created a Rails-based application that uses multi-factor authentication. Our multi-factor authentication that we talk about in the paper is using a YubiKey. Ideally that we have a username, password, and a YubiKey entry form into our web application. And that's backed by a hardware security module on our internally run validation server. Once they actually log in and they request a container, each admin is put into their own separate Docker container that is preceded with their SSH key. So this container will allow connectivity to the what we call the cloud controller network or any sensitive network that you're looking to protect with this. We have an audit manager that's running on the bastion host, and since the nice thing about containers is you can introspect into what's happening inside the container, what we can do is on the host run our audit manager and pull those logs and put them somewhere else for later review. And finally, we don't persist those containers. So once the admin is done with their task, that container goes away. So even if the laptop was compromised and they tried to leave something behind in this container, it would be gone when they logged out because the container would be removed, and the next time they logged in, it would be a fresh container. So to get an idea of what this looks like practically, users are presented with a login or welcome screen after they do log in. They simply add a key into the web interface. They create a new session, so that key that they just added is there. And after they click Spawn Container, they get a list of their current open sessions and the port. So then the person would take this information, do SSH space -p 49156 in this case, space hostname, and they would be put into that container. We looked at using containers because VMs were probably going to be too slow for this. If we're looking to replace the way that folks access remote networks, we don't want to create something that's the admin is going to click, wait a couple minutes, and then be able to access their network, right? Because there are other alternative methods that just work without having to do that. So containers are extremely quick to instantiate and delete. The time spent waiting after clicking that spawn container button is within 100 milliseconds or less, and the same for delete as well, and that's even better at 30 milliseconds or less. And the overhead to the actual bastion host is considerably tiny, right, because they're not a full hypervisor. So we're looking at about 4.5 megs to actually perform admin tasks. So you can cram one of these bastion hosts full of containers, and the load to the CPU use is negligible. We used CAdvisor, which is a Google tool, to actually measure the output of how much overhead that this container was taking. So that's how we kind of got these numbers. looking at some of the attacks that we did try, and this slide is a little bit outdated as of like last week. So when we wrote the paper, we tried to do some denial of service attacks to the bastion host itself. So we tried to fill the file system. I just ran DD in a container to see how much I could impact the bastion host itself. We were successful in doing this, though there are workarounds that could work for this. But at the time of writing, I said that user namespaces would probably make this significantly more difficult, because you could then start adding quota support into each container and start limiting the amount of space that they could take up on a per container basis. Similarly, as far as network protection goes, the out of the box, Docker does not actually prohibit container-to-container communication, and I'm sure this is probably a little bit more. There are more options for this now that there is a networking stack within Docker and plugins and whatnot. But at the time of writing, which I believe was around Docker 1.5 or 1.6, we took the we went and disabled that container-to-container communication, and further tweaked with IP tables to make sure that you could SSH into the container, but you couldn't really exfil binaries and data out of it using SCP or other processes. Similarly, we did some work in looking at how to jump out of this container. We tried to make this hard by giving the admin user only user privileges within this container, so they don't SSH to this container and have root, because that would be kind of giving it away. We think that SELinux would make this much harder to do, even if they did get root inside the container. And again, this kind of, I don't want to say it's solved by user namespaces, because as was told to me earlier this week, that code is extremely new and it hasn't been tested in production. So I think that it's definitely in the right track, but we need to do some more evaluation to really figure out if that solves our problems. But user namespaces were merged into Docker 1.9, so we're looking forward to looking at that soon. So to kind of wrap up, we think that unauthorized access to control networks and cloud controller networks are not a good thing, as you can imagine, and really do allow an attacker to take over your organization in ways you probably don't want them to. Our architecture provides a way to monitor your admins and protect your sensitive control networks, and lets your system admins relax a little bit, because you're less of a liability now. And we have our code up on GitHub. If you go to github.com/mittllcyber, we have it's a little microservice-ish architecture. So there's a couple repos there, and we could really appreciate your help if you do decide to go down this road, and we'd appreciate your commits. So with that, thank you very much. And I'd be happy to entertain your questions, thoughts, tomatoes, shaking of fists. Just go, if you're going to do a question, go grab the mic so that everyone can hear it and I don't have to repeat it.
Thanks. I'm good friends. It's really tempting to ask a silly question, but turns out I have a real question. So I really like that you tried attacking your own system in many of the ways that I thought when you were first describing it that I would attack it. That's pretty cool. I was wondering if you are setting up Docker so that each instance of Docker has an external IP, and if you could be subject to IP allocation.
Sure. Well, that's why in the interface I give a host end port, because I'm sidestepping that entire thing by just putting people on different ports.
Nice. So you have, with a IP pool, you have virtually limitless. Then.
Right.
That's nice. Okay.
Well, I mean, unless there's going to have, some 5-digit number of admins accessing everything at the same time.
Okay. All right. And another follow-up question. Do you think that this work would have an appreciable impact on an intentional exfiltration of a rogue employee a la Snowden?
Well, so one of the things that I set up when creating the architecture where specific IP table rules so that you could SSH into this container, but actually SCPing stuff back out to the internet or to your machine was really difficult. So I guess you could screen grab some binary and paste it into a file. For those particular, like trying to capture database instances, or screen grab, Etsy Shadow if it were not, properly protected, or replace Shadow with your file of choice. But as far as like getting like a giant amount of data out in an easy form, it's made a little bit harder. Thanks.
Did you look at, as part of the logging auditing process, keystroke capture, command line capture?
Oh, wow. I didn't even mention that. Thank you. Yes, I did actually. So what we do for that, in each container, there's a tool called sudo sh running. And sudo sh logs keyboard and TTY output to a file in the container. And that's what the host audit logger is actually looking for and sending off to another machine, right? So, and if we try to kill that sudo sh process within the container dies. So, I mean, you can try to get around that. There are a few ways to get around that we need to work on a little more. But for the majority of folks that are typing and not curl bashing, we did take that into consideration.
Oh, and your previous answer reminded me of one more question. For the issue of exfiltration, is there anything to stop the users from exfiltrating through the SSH session, like say running Kermit on both sides?
Yeah, that's a little bit harder. So yeah, there are definitely ways to deal with the exfil. It looks like you might have took Mike C's question. There are definitely ways around this. We're trying to limit the impact for the admin who, types some wrong commands in a router, or is trying to steal secrets off there. We do need to do more work to kind of firm up that story. And if there are no other questions, then thank you very much.